Having explored the specialized arsenal of modern elite units and how special operations reshaped 21st century warfare, we now turn to a different side of innovation: the weapons that never truly saw service. Throughout history, for every weapon that defined an era, countless others remained confined to the drawing board, the testing ground, or the junkyard. These experimental and abandoned prototypes, from World War II wonder weapon dreams to Cold War oddities, represent the ambitious, the brilliant, and the utterly impractical visions of military engineers. The crucible of World War II, with its existential stakes, pushed nations to explore radical new military technologies. Desperate for a decisive advantage, particularly as the tide turned against them, Nazi Germany famously pursued the concept of Wunderwaffen or wonder weapons. These projects, often fueled by Hitler's personal obsessions and the Third Reich's advanced engineering capabilities, aimed to create revolutionary armaments that could reverse the course of the war. One of the most extreme manifestations of this wonder weapon philosophy was the Panzerkampfwagen 8 Maus, or Maus. Conceived in 1942, this super-heavy tank was born from Adolf Hitler's belief that sheer size and impenetrable armor would dominate any battlefield. It represented the apex of German heavy tank design, intended to be a mobile fortress capable of smashing through any Allied defense. Designed by Ferdinand Porsche, the Maus weighed an astonishing 188 tons, making it the heaviest fully enclosed armored fighting vehicle ever built. Its main armament was a formidable 12.8 cm KWK-44L/55 gun, complemented by a coaxial 7.5 cm KWK-44L/36.5 gun. Testing commenced in late 1943 at Böblingen and later at the Kummersdorf Proving Grounds, where its immense weight immediately presented insurmountable logistical challenges. Despite Hitler's initial enthusiasm, the impracticalities of the Maus quickly became apparent. Its immense weight meant it could not cross most bridges, requiring a complex deep weighting system, and its top speed barely exceeded 20 km per hour. Only 2 prototypes were ever built, and production was halted in late 1944. Both were destroyed by German forces to prevent capture by the advancing Red Army, with one eventually being reassembled by the Soviets from salvaged parts. Another ambitious German project was the Horten Ho 229, a radical flying wing jet fighter bomber. Developed by the brothers Reimar and Walter Horten, this aircraft was intended to meet Hermann Göring's 3x1000 requirement, carrying 1,000 kilograms of bombs over 1,000 kilometers at 1,000 kilometers per hour. Its sleek, tailless design was far ahead of its time, incorporating advanced aerodynamic principles. The Ho 229 featured 2 Junkers Jumo 004 turbojet engines and was primarily constructed from wood, specifically plywood, making it remarkably lightweight for its size. This unusual construction also inadvertently gave it some radar-absorbing qualities, a precursor to modern stealth technology. Its revolutionary design promised superior speed and maneuverability, posing a significant threat to Allied air superiority. Several prototypes of the Ho 229 were built and flown, with the Ho 229 V2 making its maiden flight in February 1945. The Ho 229 V3, a more advanced version, was nearing completion when the war ended. In April 1945, U.S. forces captured the V3 during Operation Seahorse, transporting it back to the United States for analysis. While never fully operational in combat, its design profoundly influenced subsequent aircraft development, notably the Northrop Grumman B-2 Spirit stealth bomber. If the Maus was ambitious, the Landkreuzer P-1000 Rat, or Rat, was utterly gargantuan, representing the ultimate fantasy of German Wunderwaffen. Approved by Hitler himself in 1942, this super-heavy tank concept dwarfed even the Maus, pushing the boundaries of engineering into the realm of the absurd. It was envisioned as a land battleship, an unstoppable force on the battlefield. The Rat was projected to weigh 1,000 tons and measure 35 meters in length. Its primary armament would consist of 2 28 cm SKC/34 naval guns, typically found on battleships, housed in a modified battleship turret. Secondary armaments included a 12.8 cm KWK-44L/55 gun, 8 2 cm Flak 38 anti-aircraft guns, and multiple 1.5 cm Mauser MG 150-115 autocannons.
Powering such a behemoth would require multiple U-boat diesel engines.
The logistical nightmare of the Rat was immense. It would have been impossible to transport, requiring new roads and bridges wherever it went, and would have been an easy target for Allied air power. In 1943, Albert Speer, the Minister of Armaments, wisely cancelled the project before any prototype could be constructed. The Rat remains a vivid symbol of the escalating, often irrational, scale of some World War II military ambitions.
Moving into the Cold War, the nuclear age brought its own share of experimental and ultimately abandoned weaponry. One such marvel was the M65 atomic cannon, famously nicknamed Atomic Annie.
Developed by the United States, this massive artillery piece was designed to deliver tactical nuclear shells onto the battlefield.
Its development began in 1949, reflecting the early Cold War desire for diverse nuclear delivery systems.
The M65 achieved its most significant moment on May 25, 1953, during the Grable shot at the Nevada test site. This marked the first and only time a nuclear artillery shell was fired in an actual test, rather than from a static tower. The 280mm W9 warhead, with a yield of 15 kilotons, exploded successfully, demonstrating the feasibility of delivering tactical nuclear weapons via cannon. Despite its impressive demonstration, the M65 atomic cannon's operational life was relatively short.
20 cannons were produced and deployed to Europe and Korea between 1953 and 1957.
However, its immense size, slow deployment time, and the rapid development of smaller, more versatile nuclear warheads and ballistic missiles, like the Honest John rocket, rendered it obsolete. By 1963, Atomic Annie was phased out of service, a powerful but ultimately impractical relic of early nuclear strategy. The Soviet Union also pursued unconventional weapons, epitomized by the Lun-class Ekranoplan, often dubbed the Caspian Sea Monster. This revolutionary ground effect vehicle blurred the lines between ship and aircraft, designed to skim just meters above the water's surface, leveraging ground effect to achieve high speeds and significant payload capacities. Its development began in the 1960s under Rostislav Alexeyev. The original prototype, the KM, Korabl maquette or ship prototype, first flew in 1966, astonishing Western intelligence. The Lun-class, a dedicated military variant, was designed as an anti-ship missile carrier. Its unique operational principle allowed it to travel faster than any ship, bypass minefields, and avoid many conventional radar systems by flying below radar horizons. The Lun-class was powered by 8 powerful Kuznetsov Mk87 turbofan engines mounted on the forward canard wings, giving it an impressive top speed of around 550 km per hour. Its primary mission was to launch 6 P-270 Moskit anti-ship missiles from launchers positioned on top of its fuselage, capable of overwhelming enemy naval forces with a high-speed, sea-skimming attack. Only one Lun-class Ekranoplan, the MD-160, was ever completed and entered service with the Soviet Black Sea Fleet in 1987. It saw limited operational use for several years, primarily for patrol and search and rescue. However, with the collapse of the Soviet Union in the early 1990s, budget cuts and a shift in military doctrine led to its retirement. It remained docked in Kaspiask, Russia, a testament to a grand, unique, and ultimately abandoned naval air concept. Across the Atlantic, the United States Army sought to develop advanced attack helicopters, leading to the Lockheed AH-56 Cheyenne in the 1960s. Emerging from lessons learned in Vietnam, where armed helicopters proved crucial but vulnerable, the Cheyenne was designed to be a high-speed, heavily armed escort and attack aircraft, incorporating numerous innovations. The AH-56 was a compound helicopter, featuring a rigid rotor system for improved stability and maneuverability, and a pusher propeller at the tail that allowed it to achieve unprecedented speeds for a helicopter over 400 km per hour. It boasted advanced avionics, a sophisticated fire control system, and a stabilized gun turret, offering superior accuracy and survivability against ground fire. Despite its technological prowess, the Cheyenne program encountered significant hurdles. Rotor instability issues emerged during testing, leading to crashes and delays. Furthermore, cost overruns escalated, and changing requirements from the U.S. Army, which wavered between a pure attack helicopter and a more versatile utility aircraft, complicated its development. It also faced competition from cheaper, simpler alternatives like the Bell AH-1 Cobra. Ultimately, after years of development and significant investment, the AH-56 Cheyenne program was cancelled in 1972. While it never saw combat, the extensive research and development poured into the Cheyenne were not entirely wasted. Many of its advanced concepts and technologies, particularly in rotor design and avionics, directly contributed to the development of subsequent generations of attack helicopters, most notably the highly successful McDonnell Douglas, now Boeing, AH-64 Apache. Across the border to Canada, the Avro Arrow represented a brilliant but ultimately tragic story of a cancelled Cold War prototype. In the mid-1950s, facing the growing threat of Soviet long-range bombers, Canada initiated a program to develop a supersonic interceptor that could defend its vast airspace. The result was the CF-105 Arrow, a formidable aircraft designed to be a peerless air defense weapon. Developed by Avro Canada, the Arrow was an advanced, twin-engined, Mach 2 Plus interceptor. It boasted an innovative Orenda Iroquois engine, an advanced fire control system known as the Hughes MX-1179, and sophisticated navigation equipment. Its performance during test flights in 1958 and 1959 was exceptional, consistently exceeding expectations and demonstrating its potential to be one of the finest interceptors of its time. Despite its success, the Avro Arrow program faced political and economic headwinds. Escalating costs, the changing nature of the Cold War threat, shifting from bombers to intercontinental ballistic missiles, and a lack of export orders led to its controversial cancellation on Black Friday, February 20, 1959, by Prime Minister John Diefenbaker. All existing arrows and tooling were ordered destroyed, a decision that remains highly debated and led to a significant brain drain of Canadian aerospace engineers to the United States, including many who contributed to NASA's Gemini and Apollo programs. Sometimes, experimental weapons ventured into truly bizarre territory. During World War II, the British conceived Project Habakkuk, an audacious plan for an unsinkable aircraft carrier made of pykrete, a composite material of ice and wood pulp. The concept, championed by Jeffrey Pike, sought to address the critical shortage of mid-Atlantic airbases for anti-submarine warfare. Pykrete was an extraordinary material, strong, slow to melt, and easily reparable. Prototypes were built and tested in Jasper National Park, Canada, demonstrating its surprising resilience. The full-scale carrier would have been colossal, requiring a vast refrigeration system and a crew of thousands. It was envisioned as a floating island capable of launching hundreds of aircraft and resisting torpedo attacks. Despite its initial promise and the ingenuity behind pykrete, Project Habakkuk was ultimately deemed too costly, too complex, and too impractical for mass production by 1943. Advances in conventional long-range aircraft and the development of escort carriers offered more conventional and feasible solutions to the Atlantic U-boat threat. Habakkuk remains a captivating footnote in military history, a testament to the extent of wartime imagination when facing desperate circumstances. These experimental and abandoned weapons, whether brilliant or bizarre, share a common thread: they pushed the boundaries of what was thought possible, even if they ultimately failed to enter active service. They reveal the relentless human drive for innovation in conflict, the constant search for a decisive edge, and the harsh realities of engineering, logistics, and political will that separate a prototype from a fielded weapon. These failures often pave the way for future successes, informing later designs and military doctrines. From the rudimentary black powder firearms that ushered in a new era of warfare, to the intricate mechanisms of medieval siege engines, the strategic brilliance of Napoleonic artillery, the devastating power of World War's weaponry, the ideological clashes of the Cold War, and the specialized arsenals of modern elite units, we have journeyed through millennia of human conflict and technological evolution. This series has chronicled humanity's relentless quest to refine the tools of war, a pursuit that, while often destructive, has paradoxically driven some of our most profound scientific and engineering advancements. As we conclude From Black Powder to Battlefield, let us reflect on this enduring legacy, understanding that the past, present, and future of weaponry continue to shape the very fabric of our world.